All right, well, good morning, good afternoon, or good evening, wherever you're joining us at. My name is Chris Battisto. I'm the current ESIP IT&I chair, and I'm joining you all remotely from St. Louis. Joining with us is the community fellow Keenan Gans, and I'd like to welcome you all to our first IT&I meeting of 2025. Joining us today is Dr. Eli Holmes, a research scientist and lead for the NMFS Open Science Project. She obtained her PhD in zoology from the University of Washington with 2 bachelor's in sciences in mechanical engineering and biology at Stanford. Dr. Holmes works to help adoption of open science and open data practices across NOAA fisheries, including serving as a NOAA representative on the White House Office of Science and Technology Subcommittee on Open Science, and including several other committees. She also works towards community capacity building, including her participation in the NASA OpenScapes co-working group, which is where I met her. Through OpenScapes, she has led several open science team trainings and hack weeks in the earth sciences. Today, she will be discussing her collaboration efforts towards the PyRocket library. And without any further ado, I would like to pass it over to you, Eli. Thanks for joining us today.
Hi, everyone. Thanks for joining today. I know it's a day of remembrance. So today I want to talk about a project we've been working on with a number of people at OpenScapes on a Python R Docker image. And this talk is it's going to be a lot about kind of the motivations and the design principles that we're striving for in creating this, and why we're creating it. I'll try to keep it fairly shortish, so we have lots of time to discuss things if you want to go into more details about the nitty-gritty or talk more generally about the issues. So this relates to work we're doing. If you're part of OpenScapes, you've heard us talk about this, of fledging. So we do a lot of workshops where we're training people, and we have a great compute platform for them. It's a JupyterHub. But then what do our participants do afterwards if they don't have access to a JupyterHub? And many of them don't. So, we've been working a lot on how can we make it easier to give them access to these environments that oftentimes are kind of complex. Like if it was just a matter of like using an environment file, YAML, you could go on to Colab, say, but it's not like that. These are complex environments often. All right. So before I go into that, I want to talk a little bit about my background. Let's see here. Here we go. Kind of explain kind of the motivations of like the design ideas that I'm bringing up and why they're important to me, or why I'm talking about them. So my background is as a basically applied mathematician, long career in time series analysis. I develop algorithms for time series analysis. I worked mainly for like 20 years on a class of problems called multivariate state space time series models, and deriving algorithms for a kind of a general class of those models. This is something that comes up a lot in fisheries, where we have these multivariate time series and unknown errors and like lots of missing values. So I did that for many, many years. And also as part of that, developed a lot of R packages. This Mars package is one of the biggest ones, or most used ones that I developed. But that was one of many R packages I developed over the years. So I've been involved in open source development for a long time, and also been involved in experimenting with different types of like open education. So this time series course that we offer at University of Washington, all that material is open source, free. We record everything. We put that all online. Some years, if we can swing it, we also allow anyone to register and watch the lectures. Yeah, so also, experimenting with these ideas of different ways that you can help users do kind of complex analytical things. And so that's a combination of like, how do you teach people? How do you give them access to the platforms? And then with these packages, how do you create packages that make it easy for people to do things? It was really during my development of the Mars package that I started thinking a lot about how you create technology to lower the barriers to use. And so thinking like not just like about documentation, that's all really important, but kind of how do you create things so that the person, as they see the idea in their mind, they are able to just engage with your software in this very intuitive way. And I was interested, well, this package that I developed was really targeted towards people who would be familiar with that equation that's right there. It's a multivariate time series equations, very, very common in this field. So you would see this in any textbook. So I was exploring ideas about how do you create the interface that rather than something that you have to learn the syntax of your package, instead you try to have the way you interact be kind of like you're interacting with an equation. And I played around with a lot of different ideas about how model specification that looks like equations. Even trying to see if, like, playing around with you upload an equation like that, a LaTeX equation, and have that create the model for you. So I just mentioned that because I've been interested a lot in how we design technology to lower those barriers to adoption by making kind of the onboarding a little less or a lot less frictionful. So that's one thing. Then back, I guess about 8 years ago, started doing some projects in India. Was going there every year, working with the Indian National Center for Ocean Information Services and doing a lot of teaching there. So again, this is a picture from a big hack week that we did. It was a 2-week hack week that we did. It was about 40 people or so. It was really super fun. And it's also, again, exploring these ideas of how do you help people use these tools and what makes it hard and what makes it easy. Then around 2020, started getting very involved with OpenScapes. So starting to move away from my mathematics work. I still do that, but like it's kind of a small component. Moving more towards this education aspect, focused on technical education. It's not just like open science, that's part of it, but a lot of it's like, how do you train, people in these kind of higher level technical skills. So I became really involved with OpenScapes. And then the last, around that time too, started getting involved with hack weeks. And then I've done a lot of hack weeks. Maybe 10 so far that I've been on the organizing committee and with different groups. And these experiences really have affected or influenced how I think about how people engage with our Jupyter hubs in our environments, and watching how these compute platforms change how the groups are interacting during these hack weeks. All right. So that's all the big background here that hopefully kind of explain why we'll talk about the things I'm talking about. Oops, let's see here. Okay. So I'm at NOAA Fisheries. That's what NMFS stands for. It's actual National Marine Fisheries Service, but now we call ourselves NOAA Fisheries. And we think a lot about, you know, how do we provide services to the public for our mission, related to our mission. So our mission is related to conservation and management of ocean marine resources. And with, you know, this was an article that came out from, you know, director of NASA, Goddard, and Zeke House father from Stripe in Berkeley. And, you know, it's got kind of a clickbaity title there, but really what it's about, or at least the big message for me, was what I bolded here. And that is this idea that as we go into a situation where the climate is changing, we're seeing things we haven't seen before, there is a need to get information out to the public, to the people, whoever uses our products, faster. We need to innovate faster. We need to put out these products faster. So how are we going to do that? What are the ways in which we innovate faster? There are lots of ways we could do that. I've been interested in the ideas about how open infrastructure can spur innovation and help people work faster by removing some of the barriers that aren't really related to their innovation. So that barrier of like setting up a complex environment and all the headaches that might go with that, not just on your computer, but I'm at a federal agency. There's a lot of headaches associated with, like, you know, hey, can I install this? Oh, no, sorry, that's not on the approved software list. You're like, but it's like a core component of what I need. So, you know, that's another barrier, and all those things are an impediment to innovation. They slow things down. They're not related to the actual hard scientific problems that you're working on or computational problems you're working on. It's just like putting, you know, grit in the wheels. And so this there's a lot of people who are exploring this idea about, you know, how does open infrastructure really speed things up and spur innovation. This is a nice article this past summer by the folks behind CryoCloud. I think a number of people on this call will be aware of CryoCloud. So I'm also involved in that. But like I said, I have been involved in a lot of hack weeks and kind of watching how people are interacting with these environments that we set up on the JupyterHub. And a really typical way that the hubs will be set up, if you're doing an event activity in which your end users, some of them use R and some of them use Python, we will design our hubs like this. So this, you've seen this before if you've been on these hubs. So you have this is your Python environment, and this is your R environment. You choose one or the other. And for the types of hubs that I'm on, it's really common for us to have a Python environment that's kind of Pangeo-like. Maybe it uses a Pangeo image, or it just kind of uses the Pangeo ecosystem of tools. And then if you're in R, it's really common for people to use the rocker images. They're really nicely designed also, same as the Pangeo images. And my observation is that, you know, this kind of design encourages siloing among your groups, that it encourages this idea that, oh, the R people need to be with the R people and the Python people need to be with the Python people. Now, technically, you know, okay, sure, you wouldn't have to do that, but that's my observation, is it kind of creates this social barrier, and also a weird kind of social barrier that you might not expect. And also what I have found working with OpenScapes is it creates this really hard maintenance issue. So like with the OpenScapes image, so on their hub, they, a lot of their events, the majority of their events are Python. And so they put a lot of maintenance and development work in their Python image, and that gets updated fairly frequently. They're adding things, but their R image doesn't get updated very often because they don't use it nearly as much. And what happens is that kind of over time, the different images kind of start to diverge in like what kind of things they offer the end user. So it's not just Python in the Python image. There's other kind of tools that are there too. And so this matters a lot to me because I'm in fisheries, and in this world, there's a lot of, well, in the fisheries world, it's dominated by R. So these are, people doing spatial statistics, or just statistics and modeling, and they typically use R. So they're all over there. And then now, as we are trying to incorporate more of the climate data, and we have a lot of climate modeling initiatives, and we want to incorporate that data, well, those people use Python. And so we need these people to work together more effectively. And, in watching this, I kind of watch how these groups are interacting. And one thing I see is like this group over here, they've got all these models, and they're like, oh, wow, okay, so to work with these people, I need to create R versions of the things that I can already do really well in Python. And that just, first off, they run into lots of problems. Some things that work really well in Python don't work really well in R. And it also seems to me like not a really good use of a highly technical person's time to create something in R that they've already created in Python. The same thing will happen on the R side, where Python people will be like, oh, hey, I want to use this complex species distribution model, something that we've got so many of those in R. They're really well developed. And then like, why would you do that? You could do that in R. But there can be sometimes this idea that, oh, well, if you know R, you can't use Python, or if you use Python, you can't use R. And my observation is that's not the case. Once you are a fairly adroit programmer, sure, it's more cumbersome to learn a new one or to work in a new one, but actually people pick it up pretty fast, especially if they're not having to write code from scratch. And a lot of times what we're doing is we're having people go through these tutorials. So like we've like prepared code for them, and they need to like tweak the code for their own purposes. All right. So, since I've got these, let's see, these two communities, I am thinking about creating these environments that will really encourage them to work together. I don't want them to think in siloing. I want them really working together. And I've recently been reading this book about the history of innovation, and they this kind of argues that one way that you spur innovation is creating these environments that get different perspective and experiences coming together and seeing each other's work and working together. And so this is another kind of reason where I'm really motivated to try to create these environments where people feel comfortable to say, if you're an R programmer, hey, go over and run these Python tutorials. And if you're a Python user, hey, run these R2 tutorials. And I don't want any friction there. I want it to feel just natural and easy. And I've actually seen how this kind of cross R Python interaction has helped spur innovation. I mainly see it on the R side because things that are really easy in Python, the R people are like, oh, wow, that's hard in R. Why is that so hard in R? It's like, oh, we just haven't put much time into figuring out how to open ZAR files in R. All right. So now after listening to all this, this is a really common response that I get from people who design these images. They'll say, Eli, what is the problem? I can just easy peasy add R to my Python environment. That's super easy. Just a few lines to a Docker file. And you can just use R in JupyterLab. Isn't that great? And then if I talk to the R people, they're like, wow, why is that so hard, Eli? It's really easy to have Python in RStudio and in the R ecosystem. We've got this great package called Reticulate. Newsflash, it's not great. If you are doing a lot of Python programming, you run into all kinds of bugs. I know this because we have a Slack channel where we are trying to debug these kind of reticulate problems all the time. But, more generally, your user, your end user, like if you're our user, we're told, hey, just use JupyterLab, it's great. They'd be like, well, I don't like this. This is a subpar environment for me. And then the Python user would say the same thing, using RStudio to program in Python. You could do that. You would, I'm certain, find it an unpleasant experience or a subpar experience. But more importantly is that the kinds of environments that we are setting up are not the simple environments. And once you start setting up these more complex geospatial environments, you get endless weird bugs when you're trying to create these Docker images. So Docker images is something where you've got everything installed, and then it's kind of like having a container of all this stuff here. And then you can, in your JupyterHub or on your computer, you can run that image, and it's going to have all this stuff in there. And we've done a lot of attempts to try to get these two worlds, this R world over here and this Python world, along with our spatial libraries, especially like GDAL there, to get it all to play nice and not to give us weird bugs. And it's been really hard. We spent, in our cloud infrastructure channel on the OpenScape Slack, endless weird bugs we're trying to debug. So this was, that experience and those those like goals about creating this like stable container image that you could drop into that is easy for users to use both Python and R for geospatial analysis was the motivation for PyRocket. We are now on version 3 of it. When we first started, we built it off a rocker image. So we took a rocker, which is a really nice R Docker image, really well developed, well maintained. Updates when new versions of R come up. They're constantly like creating extensions for like geospatial and machine learning. So it's really nice base image if you're doing R. And so at first what we did is we had the base image be rocker, so it's this like R set up for R, and then we would add on this Python environment and then try to mimic the Pangeo environment. And so by mimicking means like the directory structure, what all the environment variables are, what the conda environment looks like, all that kind of stuff. We tried to mimic that. And got into the problem. It was just too hard to maintain. The Python, like I said, the Python image was being updated a lot, and then trying to merge all those changes into this other image that had a different base image. So this kind of different image with this rocker base image and incorporating all those changes in, it was like getting really hard to maintain. In fact, we didn't maintain it. We just wouldn't update the R image. So at that point, Carl Bettiger and I, he's the developer, one of the developers of the rocker image, we started working together and trying to figure out how can we make it easier to get this nice Python environment into the rocker, into this image, and have it separate from what's going on the R side, because a lot of our conflicts were we weren't keeping the Python and the R parts separate. So we did that. Still hard, wasn't quite working. And now we're on version 3, and that's what I'm going to show you today. And this is kind of ripped the whole thing apart and reapproached it to say, okay, the whole design of how we're doing this is not working. We need to use a different type of design. And we need to make sure these are the key things. We need to create a design where these two sides play nice together. We're not getting weird errors about not being able to open netcdfs, for example. Also, it needs to be way easier for us to maintain. So this is the approach that version 3 is taking, this new type of design. And so a big change in the maintenance is to say, we are not going to design our own Docker files. We're not going to design that code. Maintaining that code is a lot of work. And there are these two communities that maintain really great, stable Docker files, lots of testing. They're heavily used, so if a problem comes up, it's going to get solved. So we don't want to try to do what those communities are doing. That's not a good use of effort. Instead, like to use their Docker code and then use their Docker code and figure out how to merge that. What we had been trying to do is actually use the images. And so these are images that are already built. And what I ran into, and this was kind of what was happening with version 2, that's the approach we took. And it just was too hard to get everything stably working. So in this new approach, I said, okay, forget that. Not using anybody else's images. I'm going to use their source code, the source code for their Docker files. And that's what version 2 does. And it doesn't change that source code very much. The key thing was to figure out how to run that code in kind of build and keep everything separate, keep these two environments separate. So I'm going to go, I'll show you kind of the design in a moment. But first, I'm going to show you what it looks like for the user. So for the user, when they open up this JupyterHub, if you've been on one of these that has Python and R, this will look really familiar. So, it looks familiar. Got a button for your Python, you got a button for RStudio, and then we also have desktop, which I'll show you in a moment. All right, so when you click on those, you're going to have different tabs that open up. In ours, there are 3 main tabs. So from the user perspective, they don't have to spin up different servers. They'll have like a tab where they have JupyterLab, and they'll have a tab where they've got RStudio. And so if you want to run some R stuff, you open your RStudio lab and you work on that, and those files, if you change files or you save things, it becomes immediately available to the Jupyter file. They're both working on the same file system. It's just like a different interface to that file system. But the key thing here is that the application environment is separate. This environment over here is in a Conda environment, and it's separate, it's contained. And the RStudio doesn't use anything in that Conda environment. That was like a really key aha, was to figure out, oh, this environment, we need to be really careful in making sure that the path is clean of anything Conda related. because that having conda in our path in this environment and having it look for binaries that are in the conda environment, that just creates endless problems. So both of these are in the Jupyter image, sorry, not the Jupyter image, the Docker image, but they operate more or less separately. The less separately is that there are shared Unix or Linux applications. So like things that you do with like apt-get install. Those they do share. We also have a desktop environment. And if you have, I guess like, I think the OpenScapes and the CryoCloud, if you've been on those, you may have seen QGIS. So they have that. A change with PyRocket is that we needed to figure out how to make it way easier for our developers who want to add applications to add them to desktop. So that was kind of a, a feature of this image, is it has some helper things that make it much easier to add applications. So for us, these are things like, what do we got there? QGIS, Coastwatch Utilities, it's something for working with ocean color, Panoply. Those are the ones I have on there right now. It also has a full suite of like publishing things like Tech and Quarto, Jupyter Book, all those things, and they all have been tested so that they work nicely with each other. All right. So let me see how I'm doing here. Time here. Okay, cool. All right. So so I said that this is building things from source. And when designing this, like I said, I didn't want to really be writing the Docker file code. It does write some of it, but the core stuff, what it does is it goes and it grabs the Docker file code from the Pangeo project, their Docker file code. It has to strip a few things off of it, but then it basically takes it verbatim. Same for the Rocker project. This part of like getting their Docker file code is helped by the fact that both of these are really well-designed Docker stacks. They're very modular, a very very clean structure, clean and predictable structure. The Rocker project in particular has a very strong modular structure. It has a base image that has all kind of like the core things that you need in this compute environment. And then when you add on things, you run these scripts that you just run the script to say add on geospatial, add on, you know, something else. So you just run scripts to add things. And the kind of the hard thing when you are doing that, when you're using these scripts, you have to design the scripts nicely so that the user can kind of put them in different orders and they still work. So there's a bit of work to design this modularity. And the Rocker project does it really well. It's really quite stable and nice. So what a PyRocket's doing, it's going out, running, it's going to their GitHub repository, it's pulling in all the Docker file code and the scripts, and then it inserts that code into this master Docker file. So it ends up being this kind of this thing that's running the Pangeo Docker file code to set up, you know, the base environment, and then it inserts the Rocker code below that, kind of does everything in the right order, so everything builds nicely. That took a bit of work to figure out the right order that things needed to be done. But now it works really well. And And then at the end, so you get this source code here, and then it does Docker build, and this is the PyRocket image that's coming out of there. Okay. So let me talk a little bit more about the design choices that were made to try to help spur innovation in the Docker image also. So there's this one thing about like you're spurring innovation by just making it easier if people drop into this environment. They can just do whatever they want. They don't have to care about installing things. And the R and the Python, play nice together, and they're not, neither side is getting weird errors. So there's that side. But there's also this side of like designing Docker images is not an easy thing. And how do we make it easier for other people who wanted to do the same thing we did, or maybe take our image and build off it? So the PyRocket is actually PyRocket base. It's a base image. And then on top of that, you add scripts to extend it. So common scripts would be like the geospatial. So the base image doesn't have geospatial. There's a script to add that geospatial to it. And as I said, designing these scripts so that they are robust, so that they don't create weird errors, that took a bit of work. So they're meant to be error out gracefully, helpful information. If the user tries to like add the script, like a script might be to say, add a series of Python packages, or add machine learning capability to the image, or add a new desktop application, those kind of things. So this helps you with that. And another thing, so this single Docker file with steps. So a common thing now with like if you've ever used Binder or Repo to Docker, there is a design where you have like files in your repository and in your directory. And then when you use Repo to Docker to build an image from that directory, it looks and it sees, oh, you have an environment.yaml with like Python packages, and it does the right thing. But in talking with a number of different JupyterHub maintainers, people who are developing Docker images, specialized Docker images for their hub, and also watching people develop these, this kind of behavior where it kind of auto-magically does the right thing actually made it really hard for people to do what they wanted. People needed a lot more control over the order in which things are happening. At the same time, like properly installing, packages into your image without like ballooning up your image. So like installing it and getting rid of all the garbage. Like that's, most people wouldn't know how to do that. Or it's not necessary for you to know how to do that. We can write a script that does that for you. And this is the approach that Rocker uses with these scripts. And so PyRocket uses that same thing, that it's using scripts to extend it. So I'll show you an example. So here's what PyRocket base comes with. It comes with a folder with all these scripts. And what that means, because they're in the folder, is that when people use the PyRocket base as the base image, these scripts are just available to them. They can say, so here's what the code might look like. If they wanted to say, install a bunch of packages. So they would do here, this is from the base. They copy that file into their Docker build environment. This is a file called Docker file. This is what this is. And then it runs this script. Now, if you've done this before, you might think, well, hey, Eli, it's easy to install Conda packages. Why don't you just do it the normal way? Well, you could, except that you can end up with a lot of extra stuff in your image and have this ballooned up image. And you don't really care about that necessarily on your computer, but when you're trying to create a Docker image, you care about not having all this extra stuff in there. You don't want it to be huge or more huge than it needs to be. Adding geospatial packages in R, now that's a case where you really want to use this script. In this case, it's using the rocker script. Again, you might say, oh, Eli, why don't you just do install SF? And I'll tell you, if you try that in a Docker image, you will quickly run into all kinds of weird errors. And the rocker community has a great script that sets everything up properly so that everything works. So like that's kind of another example where like the thing you might like immediately come to mind, just do install dot packages, SF, and that would work. SF is a really common spatial package in R. All right. So next thing is user-centered documentation written with the eye to extension. So when you're developing something and you're programming something like this, it's really easy, especially like a Docker image, honestly, like why would you write documentation? It's like the Docker image is the thing, it's the product. But if you have an eye towards, well, hey, I want somebody to be able to do what I did and use my ideas, they might want to do the same thing, but sort of change it. Writing like exactly why you wrote this Docker file the way you did, why you made those design decisions is really helpful for the next person who wants to do something similar. And so as I was developing this, I hand in hand would write the documentation. So the first chapter here on using it, I did that once I got the base kind of features going. So I'm not like leaving the documentation off to the end. I'm doing it as I'm developing, as I'm writing the customization scripts, keeping that in there. Sort of everything I could think of that someone might need to know. And then this whole developer notes is all like the nitty-gritties of things, places where I got really stuck. All right, so let's see. And I said I was going to go fast, and here I'm going on and on. Okay, so I'm not going to jump onto there. We can do that afterwards. But I want to talk about this part of my talk, which says collaboration across diverse user platforms. And so far, I've been talking just about JupyterHubs. A big motivation has been trying to figure out how do we create images that are easy to use in other contexts. So we are interested in, like, ideally what we would like is the user has like an icon on their desktop and they could just click that and it would start up in this environment and they wouldn't have to think about anything and it would just work great. And maybe if they wanted to use it in the cloud, that, I don't know, there'd be another button that would click that. So that's what we'd like. We're not even remotely close to that, but that's kind of the dream, to like remove any friction for like dropping into these environments that we've set up for people. So we're not there, not even close. Instead been trying to, figure out, are there ways you can change the image so that it makes it easier to launch in some of these free compute resources. So for example, CodeSpace is one. Also, this first one here is like how to have the person run the image on their just in their laptop, like you could run this on your computer. And that looks really nice, except when you start doing real things, you do things like run out of memory. And so there's still a lot of, quite a bit of tweaking to actually make a Docker run command easy. But I want to show you this, this code space one. So we've been playing around with this a lot. This is our full Docker stack. I've been talking about the PyRocket base, but this is a base for a bunch of, bunch of other images, which I'm going to show you here. Okay. Let's go here. Okay. So this is the base, and then we add all these things to it. So this sets up the base environment, what kind of applications are there. And then these are adding like packages and GDAL and all that kind of stuff. So I want to show you, let's see if it's still running. Yay. Okay. So if you go here, we have this button, launch code space. And so we've been playing a lot with like, how can we create these buttons that you can click and it launches you right into a Jupyter Hub-like environment. So not quite there, but right now we have designed these dev containers that at least they do this. If I click on that button, it takes a while to spin up. So I did it beforehand, but after it's all like gone through in the 5 minutes it takes, you will see this, and hopefully it'll work. There we go. I click that. Come on, work. Yeah, there we go. Okay, great. So now I have this environment be the same for my users as when they're on my JupyterHub. They can go here. They have the RStudio. This was the same environment that they were on in the JupyterHub, but now they have spun it up in GitHub code spaces. Everyone has like at least now, a free allotment on code spaces. So potentially, anybody could click that. It's kind of like if you've like shared notebooks with like Colab, you can create a button, hey, open in Colab or open in Binder. Kind of the same idea. They don't have to sign up for anything except GitHub, and they would be able to drop into, this kind of environment. All right, I'm going to stop there. And yeah, see what kind of questions you have, if any.
Awesome. Thank you so much.
Yeah.
So we've got about 10 minutes for questions. If anybody would like to, please go ahead and unmute. Just looking through the comments here from Leslie Shee, also through ESIP. USGS started blocking Conda. That's unbelievable. And I'm not really sure why that is. I know that a lot of different agencies have started kind of budgeting back in terms of the pro subscription, but the fact that this library can run like you've been configuring with those GitHub code spaces, the free environment, you don't have to worry about setting up Docker. Even with the free tier is just awesome. I'm really hoping that as we start to get more R tutorials over at JezDisk, that we can use that button. I mean, that's just huge. And being able to set up the documentation for it too, I think kind of demystifies it. So thank you so much for your hard work on this. It's just been on top of all the other work you're doing concurrently. So
yeah, so I didn't put on there, but I also spent some time trying to get these images running on Google Workstations. And it's easy enough in my personal Google Workstations account. So if you haven't played with it, Google Workstations is it's a little different than like a Google virtual machine. It is a Google virtual machine, but they are these workstations that you can predefine with, what the image is and what the size is. And then, so if you're an organization, you can make these workstations available to people to be able to select and spin up. And at NOAA Fisheries, we use Google cloud, and we have these workstations, and we can get images in our like sort of approved like bucket of images we can use. And so one idea is that, if we have those images there, people would have access to these things that are not having to install anything. Unfortunately, like some of the networking things has been hard to, the extra security has created some things that are hard to debug, and Google wasn't very helpful, or their IT staff. So,
And I think even you're also lighting up my phone when you say the G word there for a second. It's also, I guess Google is one of those other ones that USGS has a hard time with as well. I remember running a couple of webinars at an ESIP a couple of years ago where we used Colab, and we had some attendees that were running into issues with that. But I think that being able to familiarize users more with that JupyterLab layout, seeing the two buttons next to each other, and seeing how consistent that is across those different environments is also huge. I guess conceptually. So when you've ran this in demos, have you had issues with, I guess, getting that kind of workflow to stick, the process of maybe, trying to communicate where this is stored? Does it go away when I close my tab? Things like that. When you've taught.
well, when I teach, we teach on our JupyterHub, and they have persistent memory.
Yeah.
We're gonna start doing a ephemeral memory, and I know I have some OpenScapes people here, and maybe you have used the like single password option for workshops where people all log on with this single password, and then they have access for the day, and then at the end everything's deleted. So we're going to be experimenting with that. But we'll be using that in situations where I wouldn't expect people to need or want persistent memory. We'll still have the persistent memory for either multi-week things or where people are doing research.
Yeah.
But we're just running so much into people not being able to install things. IT saying, yeah, you need software approval for XYZ, or just not having the even though that software is approved in, say, another center. We're all NOAA Fisheries, but one science center, they'll be like, oh, and another one will be, oh yeah, of course, how would you get your work done if you didn't have that? And so seeing if we can get like these images that are approved that everyone can use, so we're not like installing things. Also, we run into this problem where people will spend weeks and weeks trying to debug errors with the spatial libraries. And, terrible, terrible use of everyone's time.
Yeah. And things that go way beyond the analysis that's trying to be run. We run into that frequently as well, just with little things, little things like Earth data login, just for the data access even. But yeah, well, I want to thank you again for joining us for this first meeting today. Despite I guess the impromptu holiday, or I guess morning. And so I want to thank you for doing this today and joining us today. I want to just give a brief announcement really quickly that we've already got our next speaker lined up for our webinar next month, and that's going to be Annie Awale, who is a coworker of mine at JESDISC, and she'll be talking about X-array data trees. Another great effort through some of these channels that I've met you through as well, especially with those Pangeo folks. I'm looking forward to that. And again, thanks for joining us. And if you want to, you can put your email in the chat. If anybody has any way to reach out to you, if you'd like. But again, thanks for joining us today, Eli. It's good to see you.
All right. Hey, thanks, Chris. Question: where is the recording? Where will it be posted?
Once it finishes up, I'll be able to get the link, and I can put that in the ESIP Slack, and then also on that reminder email I sent out.
Okay, excellent.
With that.
Okay, great.
All right. Okay.
Awesome. Good.
Take care.
Okay, thank you again, Keenan. I appreciate it. And good to see you, Aaron.
China, hey, good to see you too.